Demonstration problem 1. Part A, Cuthbert applies a constant horizontal push F sub P to a block of mass 1.5 kilograms, causing it to move along a horizontal surface at a constant speed of 5 meters per second. Constant frictional force F sub F is the notation of 2 newtons opposes this motion. What's the acceleration of the block? Part B, what is the total horizontal force on the block? Part C, what is the magnitude of the pushing force F sub P? For these kind of problems, we draw free body diagrams. We first of all draw the block on a horizontal surface. We then indicate all forces on the body with arrows. Here's the push, F sub P is horizontal. There is a frictional force, F sub F, that opposes the motion. It's between the bottom of the block and the horizontal surface. The gravitational force or weight force, F sub W, acts at a distance from the center of the earth. There's no contact here. It acts downward. The horizontal surface applies a normal force, F sub N, on the block, pushing upwards on the block. The next step in drawing a free body diagram is to collapse the body, in this case the block, to a particle at its center of gravity, denoted here. We then place the tails of all the force vectors at the origin of this coordinate system, or the particle, the center of gravity of the particle. So here's F sub P, here's the frictional force, F sub F, acting in the negative x-axis direction. The normal force, F sub N, acts in a positive y-axis direction, and the weight force, F sub W, acts in the negative y-axis direction. The givens: the mass is 1.5 kilograms. That's a scalar. Velocity is a vector, so we must denote both the x and y components. V sub x is 5 meters per second. However, since this is a horizontal surface, V sub y, the velocity in the y direction, is 0. The block is not moving upwards or downwards. The frictional force, F sub F, has a direction that is in the negative x-axis direction. That means it is a negative 2 newtons. The unknown for part A. What is the acceleration of the block? Acceleration is a vector. Therefore, we must talk about both its x and y components. What we want here is the acceleration in the x direction, because the block is at rest in the y direction, which means its velocity is constant, which means the acceleration in the y direction, a sub y, is 0. To answer part A about the acceleration of the block along the x-axis, we note that V sub x is a constant 5 meters per second. Since the velocity in the x direction is constant, the acceleration in the x direction is 0, because by definition, acceleration is a change in velocity. The unknown for part B is what's the total horizontal force on the block. Symbolically, this is F net of x. What is it? The equation. By the first law, if velocity is constant along the x-axis, which it is here, then the total force along the x-axis, or F net of x, is 0, as depicted here. But the total force along the x-axis is also the sum of the forces along the x-axis. We go to our free body diagram to get this. We have F sub P, which is in a positive x direction, so it is positive, plus a negative, F sub F, the frictional force. It is in the negative x-axis direction. So we have F sub P minus F sub F is 0 by Newton's first law. Substitute. The frictional force is 2 newtons. We already have the minus sign to indicate us along the negative x-axis. We get F sub P minus 2 newtons is 0, or the pushing force is 2 newtons.